In this screencast, I'd like to briefly discuss the properties of vector addition, scalar multiplication, vector subtraction, and then linear combinations of vectors. First, we're going to start with vector addition. The idea of vector addition, if you have two vectors, say 1, 2, and 3, 1, is if I want to add them, well, treat them as if they were just numbers, but remove the bottom. 1 plus 3 is 4, or 2 plus 1 is 3. So just add component-wise. That's simply vector addition. What does it mean geometrically? A vector can be written as an arrow, so I could take the vector 1, 2, and draw it as an arrow with its base at the origin. I could also draw the vector 3, 1 over 3, up 1, and that gives me another vector. Well, what in the world is the vector addition? The idea is I can follow one vector and then follow another. So let's take the second vector, pick it up, and move it so that its tail is at the head of the first. And then I'm starting here, follow the first, follow the second, which results in a new vector. That new vector is precisely the sum, should be 4, 3. So notice it goes over 4 and it goes up 3. That is vector addition. Next, it's time to talk about scalar multiplication. When I take a vector such as the vector 1, 2, notice here I wrote the vector as a row vector, here I'm writing it as a column vector. For reasons we'll discover throughout the semester, I think thinking of column vectors as the vector to use is most often my preferred method. We've got the vector 1, 2. Well, if I want to take that vector 1, 2 and times it by 2, the 2 just means double all the entries, so that's a 2, 4. Well, geometrically, what does that mean? If I take the vector 1, 2 and double the entries, that's the same thing as taking the vector and stretching it to double its length. So we now have the vector 2, 4. So scalar multiplication is stretching vectors. At this point, it's time to look at what happens if I take a vector such as 3, 1 and multiply it by a negative. Well, that would just mean let's take the vector 3, 1. And if I'm going to stretch it, well, what is a negative sign? A negative sign means turn it around. That's what the vector negative 3, 1 would do. So it's negative 3, negative 1. So we've got vector addition. Using the parallelogram law of addition, we have scalar multiplication, which is stretching or reflecting vectors. And now we have linear combinations. A linear combinations of vectors, so if you take 1, 2, and 3, 1, and I perform a linear combination, all that is it means take the vectors, stretch them a little, and then sum the result together. Well, you can do this algebraically simply by just, well, we've got a 2 times a 1, which is a 2 minus 3. Or we have 2 times 2 minus 1 times 1, which gives simply negative 1, 3. Geometrically, what does that mean? Same thing as we've done before. We're going to take the 1, 2. So we've got 1, 2. I'm going to take this vector and I'm going to double its length, giving me a new vector. I'm now going to take the vector 3, 1. I'm going to turn it around. And now, if I want to add vectors, think of this as plus a new vector. The way you add vectors is you pick one up and move it so that it's positioned with its tail at the head of the other. And now we have the vector negative 1, 3. Right there. So if I take a vector u and a vector v and multiply by u by some constant and multiply v by some constant, and I even may add more, then really all that is I'm taking the vector u, taking the vector v, and taking perhaps some other vector w, and I'm going to stretch u a little. I may turn v around, then w, do something else with it. And then I want to add the vectors together. How do you add? Pick this one up, put it there. Pick this one up, put it there. And the new vector starts at the origin and heads to the tip of the third. A linear combination of vectors is just a bunch of vectors times by some constants, add it all up. And that completes this webcast.